Good evening. What a crowd. I thought I was going to talk to about 50 people down here. This is really exciting. It's exciting to be at Vero Beach at long last, and it's exciting to see the community interest in Vero Beach. Indeed, it was just mentioned that Vero Man may well be the oldest human found yet in the Americas, but we don't know that for sure, and we're going to have to find out. And was definitely associated with some very, very old Pleistocene or Ice Age animals. And so my guess is he was probably an Ice Age hunter. So I look forward to, with great anticipation, the future research that's going to go on here that may answer some really important questions on who were the first Americans. So go after it, gang. And when you find it, give me a call and I'll come down. As was just mentioned, when we all went to school, and those kids going to school today, when they hear about the first Americans, they hear about people crossing the Bering Land Bridge, coming down, why is this echoing? Am I getting too far up? Coming across the Bering Land Bridge, being blocked by glaciers that spread from Hudson's Bay all the way to the Pacific coast of Canada, waiting in Alaska till they melted, and then they hopped on down to the lower 48, as the Alaskans say, and ate all the mammoths. Cool, that's what we heard, right? The great extinction of the mammoths was caused by hunters sneaking up on these poor, unknown beasts, didn't know what this animal was that was going to kill them. Baloney. When I was am I doing something wrong here? Do I need to be behind this? All right, we'll try this. It was the theory, and there was a good reason for the theory, but it was only a theory. And that was because of the first finds of Clovis people, and Clovis people made very distinctive artifacts that I'll show you some pictures so you know what they look like, but they're spear points that are flaked on both sides, and they have what we call flutes. Very distinctive. We find them from the east coast of the United States to the west coast. We find them from the plains of Alberta down as far as Venezuela. And with radiocarbon dates, it turns out that that spread of a technology happened in about 200 years. That's an amazing movement across a very large area that it took technologically sophisticated people like the Europeans in the last century, several hundred years to do with horses and all sorts of conveniences. But as a graduate student at the University of New Mexico, I decided to go up and prove the hypothesis in 1967, and we didn't find anything. But that's because Alaska's a big place, and we looked in the wrong places, and so for a good 30 years, or a good 1/3 of my career, I spent going to Alaska, excavating sites and looking for the first Americans. And we always knew that if we could ever get to Siberia, the answer would be there. Well, we finally did, and the answer was there. Clovis people were never there. Clovis, as I wrote shortly after some of this work, was an American invention. But if Clovis was an American invention, where did Clovis people, ancestors, come from? Well, of course, they had to come from Asia. Native Americans look like Asians, so they all came from Asia. Makes sense. Even Christopher Columbus thought that. But it's just a hypothesis. And after many years, we never found Clovis or anything remotely similar to Clovis that would have evolved into Clovis. This became pretty concerning to me. And then I started looking down actually here in Florida and looking for a technology that I thought might evolve into Clovis, and I found one. It's comes under a number of names here in Florida, but it's a projectile point style and culture that's associated with blades and blade cores and large projectile points, sometimes called Page-Ladson points, sometimes called Simpson. Many of you people here probably know these names. And I published a paper in The Origin of Clovis when I suggested maybe Clovis developed in Florida out of those technologies. Boy, did that make some of my colleagues really mad. Well, they couldn't be. How'd they get to Florida? I don't know. I don't know, but it's sure the technology looks like early pre-Clovis material to me, and they said, nah, it's late. Okay, you're the experts. Then I had the timidity to write in a book that Bob Humphrey and I did called Pre-Ano Cultures of the Americas, that probably the reason we've never been able to identify Clovis ancestors and where the Clovis people came from is because their ancestors made artifacts that everybody finds in all contexts, and they all say, oh, we know what that is, it's an archaic point. And that's exactly what happened at the Meadowcroft Rock Shelter in Pennsylvania when one of the first early sites in the Americas was found and excavated correctly by James Ottavasio. And one of the leading Paleoindian geologists, archaeologists, Van Tain, says, looked at the projectile point and says, that's not a pre-Clovis point, that's archaic. Well, he was wrong. What I want you to go away with, I think right now I'm going to give you the conclusions and then show you how I arrived at those conclusions and so show you how they fit in with the archaeology. First of all Native Americans did not come across the Bering Land Bridge down the ice-free corridor. Some did, and they did it around 14,000 years ago. They had a technology that comes straight out of Siberia, which is a totally different technology using microblades, little thin slivers of rock, incised into bone that they made knives and projectile points out of. Then we think that the Clovis people, ancestors came from, as you just recently heard, Western Europe by boat. But they weren't Europeans as we believe of Europeans today. They were Paleolithic people. We have not found their skeletons. We don't know who they are. We wouldn't ever think of giving them a racial classification, and they likely came from North Africa. And that shuts down some discussion. And I think there's a real possibility that people came from Africa directly, probably related to Solutrean, but Solutrean in North Africa out of Tangiers, and landed in the Gulf Coast areas and in Venezuela. And we also think that people came across the South Pacific probably as much as 25 to 30,000 years ago, and this is all pure speculation. But the reason that we have this speculation is, one, so it gives a student a foothold of some place to start, but two, we know that boats were developed in the South Pacific maybe more than 60,000 years ago. And people were out on that ocean 60,000 years ago, and they were going to places that were really small targets, like New Ireland, New Britain, with navigation skills that were extremely primitive and primarily navigating by stars and those kinds of romantic things. And they got to South America. They got to South America a long time before Monte Verde. That's a speculation that needs to be worked on, but I have some pretty good reasons for thinking that. And 2 or 3, 1, 2, 3, 4, there were people coming out of the area of southeastern Asia, would be Japan now, and coming around the North Pacific Rim. And being out on that ocean, and if you've all heard of Kennewick Man, a 9,000-year-old skeleton found in the Tri-Cities area near Washington, or in Washington. As we've been studying him, we were in a very long, protracted lawsuit over being able to work on that particular human. But he had a great story to tell, and we're ready to tell it. We will be putting a book to press here shortly, having fought the Corps of Engineers for many years. It's now getting ready to be published. And that man is from Southeast Asia, and if you look at the population of Southeast Asia in toto, the persons that he most likely resembles are from Fiji. So the issue is then very, very complex, and the Americas have been a mixing bowl long before Columbus. Now, I want to get into the Solutrean issue and tell you why people get out on the ocean, particularly during the coldest period of the last 30,000 years. And I think you'll find it pretty interesting. I had, in my youth, when I was young and pretty, hung out with a lot of Inuit people while I was writing my dissertation, and I have hunted whales, primitive style, seals. I've been out on that ice. I'm going to show you some pictures, and it is a different world, but it's one that can be understood. And so I'm going to move on. I hope I don't get too technical. This is the people crossing the Bering Land Bridge. What's wrong with it? They're going the wrong direction. The Bering Land Bridge during the last ice age was probably the coldest place in the world. And it still is. It's underwater though. And even if it was a land bridge, it was dark many months out of the year. It was wet in the summer. And the only time you could cross it without a boat or without big high waders would have been in the winter. But people did do it. But that began to worry me a little bit as I hung out with my friends. And I started looking at the distribution of Clovis around the country. And as I mentioned, Clovis goes from the East Coast to the West Coast. And here's a picture of recorded Clovis sites in what we call the Delmarva Peninsula, for those of you who know the Eastern Shore and the Chesapeake. This is the area where a number of Clovis sites have been recorded. And there are more Clovis sites. Look at the scale of this map. It's 20 kilometers, 20 miles. That whole area would fit in Carbon County, Wyoming, where I grew up, and there wasn't any Clovis sites. That began to worry me a whole lot. Why are there so many Clovis sites on the east coast of North America? Fact is, there are more sites there than there are in the entire Rocky Mountain West. I am sorry, folks. They've been on there a long time. And then it began to be really clear that there were probably more Clovis people here a whole lot longer than the radiocarbon dates would suggest, and sites were extremely huge. For instance, this is a site in Tennessee called Carson Con Short. All of the things that you see out here that look sort of white are probably Clovis artifacts. And this is in the Kentucky Reservoir. And when they let the water out, then all this Clovis stuff appears. And the site's about 1.5 miles long by 1 mile wide, or 1/4 mile wide. And we've, John Brewster, the Middle Tennessee state archaeologist who's worked on that, has probably taken out more Clovis artifacts than would fill the Smithsonian. It's a huge site, full of blades and blade cores. This is a blade core They fixed the stone so you can hit it at the top and drive off these nice long slender blades and turn those into artifacts. Then more recently at another site in Tennessee, a farmer was sold all the timber here above the river, and as it turns out there's a chert outcrop, an outcrop of flint right over the edge. And after he sold the timber off, he root raked that whole area. And as it turns out, as he turned over the dirt root raking, these are all Clovis artifacts. And they go all the way down to that tree line, and I suspect that's a different property. I suspect that if we go over there and dig, the Clovis stuff is in place. These are huge sites. Here's some of the material that was collected in one afternoon, large Clovis cores and bifaces. This is the gentleman who's collecting it. He lives right there. He lives in one of these old dog houses with the dog runs so you get on through it. He's got these buckets and tables and things piled all the way around. They're full of Clovis artifacts. So where did Clovis come from? In 2001, I was invited to go to Solutreans in France and do an exhibit with the French archaeologist on large ceremonial biface caches. And what a large ceremonial biface cache is that Clovis people would make great big artifacts, very exquisitely made, and do 15, 20, we've seen as high as 100 in a cache, and just bury them. We don't know why, but the Solutrean people did the same thing. So the French archaeologists asked us, "Oh, bring over your Clovis stuff and we'll have a big exhibit on these caches." And I said, okay. So we did that, but before we went, a team digging down in Virginia at a place called Cactus Hill had hit a site in which they had Clovis artifacts, and as they excavated down underneath it, they got more layers of artifacts. And here you see at Cactus Hill, this is from the Clovis level, and then the lower line is from the pre-Clovis Cactus Hill level. And it was pretty clear we had a stratigraphic situation, although some of the naysayers said, "Oh no, it's got to be mixed," and blah, 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 blah. And both Vance Haynes and I were there, and we thought, well, this is real interesting. Don't know what to make of it. And then I went off to France, and we did the exhibit. And while I was there, I began to see the Solutrean artifacts. And the Solutrean projectile points look just like these two right here. I said, "Wow, that's kind of interesting." Now, people have pointed out for many years that there's a lot of similarity between Solutrean and Clovis technology. However, it was an impossible relationship because of the oceans out there. You know, the Titanic can't get across. How could Alley-oop and his caveman buddies get across? You know? Oh, and by the way, the Solutrean is 5,000 to 6,000 years older than Clovis, so it can't possibly be. Well, that, you know, using that logic, that's true. When I got back to Washington, D.C., after being in France and in Spain and looking at that material, they had a radiocarbon date on this level. The radiocarbon date was 16,900. Bam! Right in the middle of the Solutrean time period. I said, very, very interesting. So I called Bruce Bradley, my co-author of the book. Bruce worked with Francois Borde. Bruce is undoubtedly one of the best and most experienced flint knappers in the world. He's worked all over the world. He knows practically every technology there is, even more so probably than the people who actually used it. So I said, "Bruce, I see what you've been talking about. Let's see if we can get a little bit of money and go over to France and Spain and see exactly what the relationships might be and how many there might be." And one thing I was really excited about finding were these Solutrean projectile points. Those of you who know anything about Clovis, how do you like those? A flute, and a flute, and a flute, and a flute. Look at that date, 22, 24. These are our guys. But not all Solutreans are our guys. They come from the sites that have the triangles. You see these green triangles? These sites have these kind of points, and the round sites have other kinds of Solutrean stuff, and there's probably something going on here ethnographically that I don't quite understand, but maybe after this book is out, the Spanish will start working on that question. So we were real excited about it, and then when we got back and found out the age of Cactus, or we knew about Cactus Hill, so we saw that we had this technology going, and it was a little more technology than what we thought. And a young man by the name of Darren Lowry, who was getting his PhD at the University of Delaware on coastal geomorphology and coastal formations, was working on the eastern shore once again where all the Clovis sites came. And he was mapping this black soil. Turned out there was a remnant of that same black soil between the Clovis and pre-Clovis at Cactus Hill. But this is loess. It's wind-blown sand that came in during the last ice age. And then a soil formed on it towards the end of the ice age, but in the Delmarva Peninsula, the end of the ice age was a lot sooner than it was in Europe. But while he was working on this section, he found this large boulder sticking out. This is wind-blown deposits. Where did the large boulder come from? So I said, Darren, he called me. I was at a meeting at Texas A&M about pre-Clovis. And I said, Darren, go out there and test that sucker and see what's around it. So he did, and look what he found. Here's the big boulder that they spotted. It's an anvil. There's a hammerstone, a wedge core, a blade flake, and another blade flake. We have an occupation level here. Our radiocarbon date, 21,000. We're moving back, folks. We're moving back, and we're moving back fast. Here's where Miles Point is relative to Washington, D.C. is over here someplace. And this is where it's the unpatterned green. This is the Atlantic Ocean in the Chesapeake Bay. And at the time the Miles Point people were living there, this was the Susquehanna River. And it appears as though these first people were living along the Susquehanna River, at least in this part of the world. And the preservation at Miles Point was great. We got charcoal, reasonable dates. We got pollen, wood fragments, so we know what the environment was like. And we got hair. Oh, that's pretty neat, isn't it? We were really in hopes it was going to be human hair. It was dogs. But that's all right. We like them. I've got a dog who's a descendant of that Canis dirus up there. She's a Japanese Akita. But we continued to work. And for the rest of you cat lovers, we got kitties out there too. We don't know which ones, but when we get more data there, we will figure that out. But what the important thing that Darren and his colleagues figured out was that this black line, black deposit, was a soil that started to develop in the eastern shore about 22 to 19,000 years ago. And it was truncated by a time period called the Younger Dryas. Now, the Younger Dryas is a period when, as it was warming up after the last glacier, all of a sudden it got real cold again. And this part of North America turned into kind of a desert. And we got wind deflation all through here. And we can follow this now on the Rappahannock River. We can follow it on the Susquehanna and the Delaware, and probably the rest we haven't looked at yet, but we're going to have a bunch of students out there doing that. And what we found was that all the Clovis sites that aren't on the surface are on the top of that soil. Below the soil, we start finding, now we're up to about 4 of these sites that have the Cactus Hill kinds of projectile points. So we're beginning to get a pretty robust group of artifacts. And we find Clovis sitting right on top of that soil, as I said. Now what that means is that that soil was a lot older than Clovis. And the Clovis artifacts were above that soil, and during the real windy time period called the Younger Dryas, that whole area deflated. So all of those Clovis sites become what we call lag gravel. They've all kind of blown down, they're all at similar level. And they all have the same radiocarbon date, oddly enough, of 10,900. We don't know when Clovis started in the Eastern Shore. Clovis may go back a whole lot older than we now think, because we now know what geologic trick was played on the people who were trying to date Clovis. So then we started looking at the continental shelf, and this is where it's going to get real fun. This is a publication that was done in 1967. The mastodons are the red triangles, and mammoths are the blue circles. And for a while, the large museums were keeping track of these when the fishermen would bring them in or they'd get found. And they published this in Science, and nobody's kept track of that ever since. And we know that a lot more of those animals have been found by the deep sea scallopers and those kinds of people. But it's kind of interesting. You can sure see that the Hudson Canyon was a big place to go hunt mastodons. Clear way out on the Georges Bank, it begins to look like we have a huge area of almost 400,000 square miles, a really prime hunting territory. Now here's the latest in good archaeological equipment. This is a deep sea scalloping boat, and Captain Thurston John was out in about 1970 with his crew, and they were working 50 miles off of the Virginia Capes, right at the edge of the continental shelf, in 250 feet of water. They dropped their scallop equipment down, started forward. That's a pretty good sized boat, and it stopped. Oh, God, we're not going to make any money today. So they reeled it up, and what do you think was in that net? A complete mastodon skull. Pain in the you know what. So what do you do when you're 50 miles out in the ocean? You got a crew out there, you need to make money, and you don't even own the boat. You're just getting a percentage of it. Let's just throw the damn thing back in the water. Well, wait, look at this ivory is in really good shape. Oh, these teeth are kind of fun. Well, get a sledgehammer, we'll just bust it all up and throw the big pieces back in the water and keep the tusk and the teeth, which they did. And I'm glad they did, for several reasons. One, I got a boat out there today as we speak, trying to find exactly where that was. But we know roughly it was right here, right at the mouth of the Norfolk Canyon, which of course then was where the Susquehanna goes into the Atlantic Ocean. And here's where he was working. But as they were taking the mammoth apart, guess what fell out? This very nice biface. We opened a new exhibit at the Smithsonian a couple years ago after I had this biface was loaned to me. And we have a new exhibit on human origins. And the Musée de l'Homme in Paris is undergoing renovation. So they loaned us the original Cro-Magnon skull and the original Neanderthal skull. And their archaeologists brought them over for exhibit. And I handed them this knife, which we know it's a knife now. And he says, oh, Solutrean, n'est-ce pas? Ah, oui, Solutrean, n'est-ce pas? Yeah. Here's our radiocarbon date on the mammoth. 22,760 plus or minus 90. Tom Stafford, who did the date, said it was the best preserved collagen you'd ever gotten. Now, does that date the knife? No. I don't know, but I wouldn't be surprised because we know from Miles Point, from Oyster Cove, we got guys out there at that point in time, so why it doesn't date it, I don't know. But we know one thing, given the rise of sea level during meltwater pulse 1A, that knife has to be over 15,000 years old and is hence the oldest formal tool yet found in the Americas. But we think it's 22,000. We found its source. Over 300 specimens at the Smithsonian Institution were collected back, most of them in the 1800s, by geologists working in the mountains of Maryland, Pennsylvania, and Virginia, collecting rhyolite, the huge rhyolite deposits there. And in 18-something, this sample right here was collected. Jeff Speakman, who many of you know, went out there with me, and we collected a lot of new samples. And then Jeff sampled all of the 300, or not all of the 300, but the major bunch of the samples there at the Smithsonian. And we know, I think, exactly where that rock comes from, because I know this is going to be a little difficult for you to see, but there is a blue line and a red line here. And this is an XRF graph that shows the percentage of various elements in that tool and in the hand sample. And you can see they're identical. So when we plot all of the distributions of the banded rhyolite in the formation, we find that the ones from Maria's furnace all cluster with our knife. Now keep that name in mind as I move on through this talk. Marvin Kay at the University of Arkansas did use wear analysis. Use wear analysis, isn't that interesting? How do you get use wear analysis on a 22,000-year-old knife that's been in the ocean? It was pretty well protected. It wasn't wave washed. It wasn't chemically altered. Its flake scars are crisp. And Marvin figured out that it was a hafted knife, with one end being where it was cutting some real heavy equipment, such as maybe mastodon fur or something, and the other end was where the handle was. So these are typical of handle work, and these are typical of knife work. So we now know we have a hafted knife. And here's the complete, these are the only three places where the iron bars of the net hit the knife. Had that been drug any further, it would have been beat to crap, let me tell you. This part, green part, is where it was hafted. The red part is where Marvin found the use wear, and he found out that the knife got dull, and whoever owned it resharpened it where it's blue, right up here, and then either lost it or threw it away. Now, we think that it's a almost 23,000-year-old knife, but the reviewers at Science didn't like it much, so to hell with them. This is banded rhyolite artifacts. These are actually pretty old artifacts for the Chesapeake, and these are ones that have been on the beach in the swash and burn zone. And they get rolled and tumbled, but they never get washed out into the ocean. They get washed along the beaches, those of you who hunt here know. If they've been in a saltwater marsh, they get attacked by the chemicals of the marsh itself, and they eventually will, if been left in the saltwater marsh, totally dissolve and be gone. If there's bones in a saltwater marsh, they may turn red. Now, what we found at Sinmar was that the mastodon bones, if they were 22,000 years old, were in a environment that caused perfect preservation. You know, like in Sweden, like in Ireland, the bog people. That mammoth was 14,000 years in a bog deposit. We think the knife was too. But as sea level rose, fortunately for us, there were Ice Age barrier islands out there, and the site's just upslope from an Ice Age barrier island channel. That when the sea level rose, and rose very rapidly on what we call meltwater pulse 1A, and that's when all our glaciers are melting back then, like they are today. And that water came up pretty fast, coming about 3 meters a century. When that water came around over that bog, it turned it into a saltwater marsh. Now, had the tools and the mammoth been in a saltwater marsh, the tool would have been gone totally. The mammoth, I don't know, would have been in bad shape. But sea level was rising so rapidly that pretty soon it was no longer a marsh. And that's when all of the sulfidization quit. So that's why we know for sure that the knife is at least 14 to 15,000 years old at the youngest. Oh, I want to go back there. So we started looking for more. The Smithsonian has a pretty good arrowhead collection, guys. If you want to come see arrowheads, we'll show you. We looked at all of the stone tools from the Mid-Atlantic area to find another Sinmar biface. Over 300,000 tools were observed. We found one more Sinmar biface. And it was number 2, off of Hampton. Oh, cool. We like that. And then Darren went around to all the artifact shows. We talked to the state archaeologists. We looked at all the collections, and those things are rare as hen's teeth, as they say. But we've now gotten, actually there's 2 that aren't on here that we just got. We did an exhibit of the Sinmar find at the Gwen Island Museum and had an identity day where we invited people to come in and bring their fossils, and the lady who runs the museum, Joan Tanner, invited all the watermen to come in if they had fossils and artifacts to show them. And we got more. We got 2 from Hopejack Bay. We got some from up in this area here. And when you plot them all out on the old river basin, and I wish I'd have brought that slide, I forgot it. Here's where the Susquehanna comes out, goes up there and comes right along here and all the way up here, right to number 6, which is the Maria's Furnace. And half of these are made out of rock from Maria's Furnace. So these guys are Solutrean guys using the Susquehanna River. And then we started finding some upshore. This is an LGM, late glacial maximum sand dune that was blowing up while the lust was coming in. And a farmer over in Matthews County was bulldozing this over, and he hit one of our guys. And it's also from Maria's Furnace. Here it is, and you can tell it's been in a sand dune. You can tell that the tractor hit it too. So yeah, pretty cool. We're getting a pretty robust database. And then you compare it to the oldest sites in the Mid-Atlantic. We have Sinmar, Cactus Hill, Miles Point, Maria's Furnace, and just over the hill, Meadowcroft. And we now have one at Oysters Point here. And I just found out within the last week, one of our biggest critics, who will remain nameless because he's going to have to write a paper, was doing a CRM project at Lee's Ford, Virginia, and got a nice Clovis occupation and 2 pre-Clovis sites underneath it. So he's going to shut up on his reviews. Now, a little technology here. These are the ones from the Chesapeake Bay, and I've got them under drawings from Solutrean sites across northern Spain and France. They're exactly the same tool. Solutrean, n'est-ce pas? Oui. Now here's the killer. I love this one. This one right here, old number A, was excavated by a historic archaeologist from Virginia. He was working on Epps Island, which is part of the Shirley 500 plantations. And he found this odd biface, but being a historic archaeologist, he recognized something that nobody else might have recognized in 1970. That one's made out of French flint. Whoa. Is it our smoking gun? I think so, but a lot of historic occupation of Epps Island in that area. But what do you think the odds are that a lowland English farmer colonizing Jamestown would have gotten a French biface made out of French flint, brought it to the New World as a souvenir, broke it, and threw it out on the ground? Nah, it's got to be considered a possibility, but I don't think so for the following reasons. Here's two more that we found in the James River drainage. And they have the same little dimple in the bottom, such as this one from Jean Bloch, and this one. And they're made out of local material from the same area. In fact, we know the outcrop of this material right here, and it was really well-loved material by Clovis people, but after Clovis you don't see artifacts made out of it because it's underwater. It was a source inundated when the sea level rose. So here again is another one of these neat little things that Jeff Speakman will do for you guys. And there are 5 lines here, different colors. There they are. French, 1, France, 2, and the gun flints. These are French gun flints, and these are from the cave of Solutrean and the Epps Island biface. Pretty much all from the same place because all of those collapsed down, and they're all French. So here's the sequence we're beginning to see, at least in the mid-Atlantic. This is a Solutrean one, Oyster Cove, Miles Point, Cactus Hill, Meadowcroft, and this one's from a site called Jefferson Island, and I think you guys are going to like Jefferson Island, so I'm going to talk about it. And here's a chart showing sea level rise, Miles Point, Sinmar, and up here is where the sea level was on the Chesapeake at Clovis time. So you can see how rapidly the sea level was rising. Now here's Jefferson Island. It's out of that 14,000-year-old soil. Does it remind you guys of anything? Kind of looks like stuff that we have here in Florida that we call Page, Ladson, Simpson, whatever. And at the Page Ladson site, there's several dates that would say that it's 14,000 years old. And that's what our dates say. So I think we had a pretty good population of people making these unfluted projectile points, as I suggested in 1991, along the East Coast. And it's beginning to show. But what's really neat about it, though, is if you look at it, all of these could be right out of a Solutrean site, every damn one of them. This flat flaking on that biface, retouch on the same biface, beer and blow, what the French call a micro-grattoir, or a little scraper. And they have the same distribution of sizes of projectile points as we get at Clovis and Blackwater Draw, which I think is fun. And we start to see the numbers of sites increasing at around 14,000, where we are actually getting pretty reasonable samples like you folks are getting here. So we're beginning to see population. We're beginning to see, I think, a population moving west. moving west because of the rise of the sea level and the younger Dryas. And the East Coast has become pretty hard living. And here is the Johnson site, which is a site in Tennessee. You can see this black lens here. We got 3 radiocarbon dates. This is John Brewster again. And the radiocarbon dates all suggest that it's around 12,000 radiocarbon years or 14,000 corrected years. That's about 50 to 75 years older than Clovis. So we're calling this Proto-Clovis. And why? These guys are trying to flute, but they're not doing a very good job. They look more like the ones we see in Europe. And we get what they call a point-à-face plan. Here's one here, which is just a blade that's flaked on one side. We get typical Solutrean blades, overshot flake, and what French have the name for these 2 scraper types that occur in Solutrean. But the next step is Clovis. Oh, there's also a site nearby called Coates-Hines, where we have a very close radiocarbon date, and it's got mastodon bones. We now have another radiocarbon date, which one of our graduate students working out at Texas A&M under Mike Waters is going to have to say, yeah, that date was right, because we got one too. And that site will be fully excavated this coming summer, and we're really excited because I think that is the transition to, from pre-Clovis to Clovis, is right there. So here's the way I look at it. Here's your radiocarbon dates for Solutrean at the top. The black lines are when it's real cold, and this is what we're calling right now the early mid-Atlantic or mid-Atlantic early Paleoamerican, which is Miles Point and that technology. Then we're calling this the early southeast or southeast early Paleoamerican, and that's some of the material we're getting right here in Florida. And then finally Clovis, and it's a little split there before all the Asians come running down the ice recorder. Now, who are these people, and have I talked way too long? DNA. It'd be nice if we had some good DNA because it would tell us who's related to who. But we don't have any Clovis burials. We don't have any Solutrean burials. So we just have to think about what it might be. And there's a DNA marker, a haplogroup, the Eve gene, known as X. And what we have drawn up here is the distribution of haplogroup X. And according to the geneticists, it arises over here in Egypt, spreads across North Africa, up into Spain, and even up onto the Orkneys in England, Spain, and then another group that comes out here becoming X2 around the Caucasus and into this part of Europe. These are Paleo-Basque, and these are probably Paleo-Sami. Then we have this stupid little thing out here. They got a bunch of X in Western Altai. And since we all know that all the Native American haplogroups, A, B, C, and D, and X, came from the Altai Mountains, and here's the solid evidence for it. Is that solid evidence for the movement of people across the world? How do you get an X gene? How do you get a mitochondrial gene? You need some women. They're going to have some kids. Does this look like 18,000 miles of human behavior to you? It doesn't to me. There's no X in any of that area. And this X gene here is likely. I say likely. What we're looking at are modern populations, by the way. These are not fossil populations. These are where X is found in living people. This is probably from the Mongols raiding the Caucasus and bringing women back in historic times. And Wallace, the guy who originally factored out the X haplogroup, agrees with that, and that's his thought. But all the rest of the geneticists who think that everybody's got to come from Asia think they do that. But I say maybe that X is our guys. And we have a little different X variation in North America. It's called X2A, and it occurs in two places. One of them here in Florida, called Windover, and one up here, these are prehistoric, and one up in Illinois. Now there's three other fossil X, and they're all over here, right exactly where we said they came from. Hey, it's my case. I'm going to rest it, I think. Y'all tired? You can go home if you want, because now I'm going to tell stories. That's what we think. That's you read the book, and that's where Bruce and I end up. But how did they do it? Why did they do it? What was life like? And those are the questions that people really want to know. Okay, so they did it. So they had boats. How'd they get boats? What'd they do? You know, it goes on and on and on. Fortunately for me, I did that work with the Eskimos back in the 60s. And I had the great pleasure of hunting. This is the kind of edge that Bruce and I envision. This edge right in here, those are pretty stable. Your sea mammals and seabirds pretty well flock in these areas here. And this type of environment connected Europe to North America. And you could actually walk it. In fact, the polar bears did. If you look at polar bear DNA, it comes right out of Western Europe. And the polar bears did, so did the fox, so did all the birds that follow the fox, and so did the people. But what were the people doing out there? They were looking for fat. If you live in an ice age environment, one of the most precious items you can get is fat. Fat to feed your body, fat to waterproof your boat, fat to cook your food, fat for light. You need to be a constant source of fat, have that available. And the problem with Ice Age Europe, there wasn't much wood. It was another issue they had going because it was, like I say, a polar desert. So they needed fat. Now, if you weren't hunting the sea mammals, the great auk, the seabirds, where are you getting your fat? The only source is going to be the red deer. Red deer is the European version of elk. Do you have any elk hunters in the group? When do you hunt elk? Hunt it in the fall. Why do you hunt it in the fall? Because that's when it's fat and it tastes good. But by December, by January, you don't have any more fat. And if you need fat, don't go to that red deer. Go down to the coast, find some seals. And the more people you get scattered out along that ice edge, hunting seals, the better the chances of surviving are. One seal will go a long way. And we don't imagine that there's a lot of people out there. There's just people out making a living. Now, the other real interesting thing is that of the seals that are really sought after are the harp seals. The Canadians have been trying to kill out harp seals for years, and in the last census there was over 5 million of them even yet. So get your clubs out and go to Canada. There are two populations of harp seals, one out of Europe, one out of Canada. And their behavior is they follow that ice edge in the summer, meet up in the summer, and then move back. And if you're hunting the ones along one part of the summer and you happen to start following the wrong ones, you're going to end up on the Grand Banks. Now this is a picture that my wife took. This is on the Arctic Ocean. This is a whaling crew. This is the whaling captain. I love him dearly. This is the Levitt whaling crew out of Point Barrow. This is Captain Jonah. BBC wanted to film one of these umiaks out on the water and the ice, and so we talked my good buddy Jonah into, and he had to talk his crew into going out there long time before whaling season. But what I want to point out here is it's 40 below zero. And there's, now all you sailors take warning, 20 knot wind. Where are the waves? Yeah, where are the waves? You don't get the waves. They don't pick up at that temperature. If it does get gnarly, and you decide, whoa, it's the wind's shifting around, let's get the hell out of here. You drive that boat right up onto the ice, like that guy did, and the first guy in the boat jumps out. And then the bow raises up and the next guy, and meanwhile they're shoving her in, and it takes you about 2 seconds to get that boat clear out of the water. First thing you have to do is get your oars all out and pound the hell out of the boat to knock the water off of it as it freezes. Then you turn it over, and the Eskimo Olympics has a lot of fun games. One of which, do you all know what pilot bread is? It's a big unsalted cracker that lasts forever. One of the Eskimo contests is who can eat the pilot bread the fastest and whistle the soonest. Try it. The one that I want to talk about is who can get their boat out of the water the fastest and have the first cup of coffee. My team won. So, you know, we're kind of an odd bunch of humans now. We got all these electronic gadgets and stuff. We don't know anything about nature anymore. Doggone few of us do. But when you lived back then, what was your entertainment? Your entertainment was survival, and how did you figure out what to do? So you learned navigation. You learned changes of weather. You listened for the wolves to howl. Why do the wolves all howl at once? They didn't know, but it meant a change in climate or a change in weather. It's the pressure. It's the barometric pressure. Just all kinds of fun things that you and I have no idea about. Hey, let's go fishing. There's where the birds are. That's the spot. And when you're out there on the ice and you see it out there in the water, you say, hey, look at that. They're teaming out there. Now, this is kind of a fun picture, too. Here we have all our trees. They get into this current here, and they get washed up in medieval times into Iceland, where there are no trees. And traditionally, families in Iceland owned beach rights for driftwood. But the majority of that driftwood comes where our guys are. And the other day when Irene came through Washington, D.C., you should have seen the logs and trees coming down. And I saw it on the Colleen River once in Alaska where I couldn't get out. My bush pilot couldn't get in and pick me up for 3 weeks because of floating trees. And these trees ended up on the coast of Spain, and they were the source of wood for everything: fuel, artifacts, housing. You know, here's a historic picture. This is clearly a summer camp, but what you do sometimes is you turn your boat over, and then in the winter you can pull a tarp down and put snow around it, and you got a sweet little house there where she's pretty happy. She's probably making coffee. If you know what you're doing, you can do it. And the Eskimos didn't learn it overnight. Took them a couple thousand years to figure it out. But how long were our Solutrean guys living close to the edge of the water? A long time, longer than the Eskimos. They needed that fat. They were out there. Don't kid yourself. Those Solutrean guys were out there. They had boats. Boats had been known for 40,000 years prior to Solutrean. That's a good idea. It goes fast because it turns oceans into highways, rivers into highways, lakes into highways, and people spread around the world. And I probably forgot a lot of stuff that you guys want to know about, but rather than keep you much longer, I wanted to point out these nice little Solutrean artifacts. This is called a point à face plan. This one's called a lamb retouch with a an E. And here's one of our n'est-ce pas, Solutrean biface. All of these are from Florida. The guys are here. The guys are here, and you will find them at Vero Beach. This is my last slide, and I just want to give you an update, so don't run out the door. Our team has been successful in finding carbon. A date will soon be available, at least on this specimen. And believe it or not, we have found chunks of DNA chain. So we don't know if there's enough yet there to say whether it's a mammoth or mastodon or a ground sloth, but we will know as soon as they get it all positioned and figured out. And then after you all dig down here some more and get more samples, I think we're going to get some real fun results. So I'll cut it off here.